All right, today we're going to explore X and Y intercepts. And we've been exploring Y-intercepts for a long time. It's an important part of our scenarios that we study. It's the flat rate. It's where the axis or our scenarios usually begin. Um, but we're also going to today explore X-intercepts. And the reason is, although we don't spend a lot of time talking about X-intercepts in grade 9, when we move on to grade 10, 11, and 12, the X-intercepts start to take over as becoming the more important characteristics of relationships than maybe even the Y-intercept is. But for grade 9, the Y-intercept is still sort of important. But today we're going to investigate both of them. So we're going to do that by starting by looking at a Desmos graph. So here's a graph and a bunch of equations. Let's look at each of them individually. So here's a line, and the Y-intercept there is 4. We're just going to look at Y-intercepts for a second. This line, the Y-intercept is 2. Here's one where the Y-intercept is 0. Here's one where the Y-intercept is negative a half. And here's one where the Y-intercept is negative 2. So all of these we probably could have gotten without graphing because they're in y equals mx plus b form. So you can see here that the plus 4 is the Y-intercept right there, and the plus 2 is the Y-intercept, and so forth. Okay, but let's look closer at those Y-intercepts. Let's actually look at the coordinates of them. So there's that one at 4, and this one at 2, and this one is at 0, and this one crosses at negative a half, and this one crosses at negative 2. Well, if you look at the coordinates of all these Y-intercepts, you'll notice one thing in common. The X values are all 0. And that kind of makes sense because if the line crosses this point, these coordinates don't go right or left. We don't go over to like 5 and then go up to 4. We go 0 and then up to 4, or 0 up to 2, or 0 down to negative 2. So all of the Y-intercepts have an X coordinate of 0. And that's going to be really helpful when we need to calculate them. So the first conclusion is that all Y-intercepts happen when X equals 0. So the Y-intercept of X equals 0. Now let's investigate the X-intercepts. So the X-intercepts, if we go back to our Desmos graph now, let's just look at where they cross the X-axis. Well, the X-intercept for this one is negative 6. That was not easy to find in our equation. I wonder how we would. Here's another one, and this one crosses at negative 2. This one crosses at negative a half. This one crosses the x-axis at 0. And this one crosses at 4. And if you look at all of the x-intercepts, you'll notice a similar thing in that all of the y values are 0. And again, that makes sense. To get to this point, you go x equals 4, but you don't go up or down because you're on the x-axis. So it's 4, 0, and 0, 0, and negative 6, 0. Now, these x-intercepts, you can't tell from the y equals mx plus b form. And so we'll need to figure out how to figure those out without the graph. So having this conclusion that all of the x-intercepts happen when y equals 0 is going to be helpful for solving these x-intercepts without a graph. And that's what our goal is today. So the x-intercepts are when the line intersects the x-axis, and it happens when y equals 0, and they look like this. And the y-intercept is when the line intersects the y-axis, and it happens when x equals 0, and they all look like this. So let's look at an example. Here's an equation, 2x plus 3y equals 12. And if you remember from our last lesson, this is an equation of a line in standard form. It turns out it's easier to find intercepts, x-intercepts especially, in standard form than it is in y equals mx plus b form. So we're going to use this version. Now, to do that, we're going to use the heading that's going to be very, very important. And if you remember, I was really stressing when we did the slope formula that you write down y equals mx, or sorry, m is y2 minus y1 over x2 minus x1. I kept asking you to write that down. Here, I'm going to ask you to write this heading down. Writing this heading down will allow me to do the algebra that follows here. And the heading is the conclusion that we discovered, that the x-intercept happens when y equals 0. So if we take this equation, 2x plus 3y equals 12, and we replace the y value with 0, we're going to be able to do some excellent math. But we can't do this replacement unless we have this heading. If you just go off and start writing this down, there's no reason why you're substituting 0. We need the heading to do that. So I'm going to ask that you always write this heading down. Now, because this is substituting 0, 3 times 0 is just 0. And 2x plus 0 is 2x. And so very quickly we get our equation simplified into something much easier. 2x equals 12. Now, to figure out what x is, we of course divide both sides by 2, and 12 divided by 2 is 6. And so it turns out that the x-intercept for this guy is 6. And we got it by substituting y equals 0. So if I wanted to graph it, I'm guessing that this line happens right there at 6. And so if we wanted to write the coordinate would be 6, 0. It goes straight to 6. Now, if you write this heading down, I know you're calculating the x-intercept. So when you finish with x equals 0, you don't necessarily have to write the coordinate down. I know that this means the x-intercept is 0. Again, another reason why you'd want to write the heading down. All right, now let's go off and find the y-intercept. Again, if this was in y equals mx plus b, it'd be easy to find, but it's not. And so we're going to use the same sort of heading. The y-intercept is when x equals 0. So the y-intercept is when x equals 0. So again, we'll take our equation, but this time we're going to substitute x equals 0. That makes our math easy. 2 times 0 is 0. 0 plus 3y is 3y equals 12. How do I solve for y? Divide both sides by 3, and 12 divided by 3 is 4. And so it turns out that the y-intercept, this line, is going to cross the y-axis at x equals 4, or y equals 4. And the coordinate would be, well, x, I don't go anywhere, x is 0, and y is 4. So the coordinate is 0, negative 4. And now, if I've got 2 points on my line, I can just take my ruler, connect them up, and I've got my drawing for my line. I don't need to rearrange in y equals mx plus b or do anything else. These 2 points will get me the equation of the line. So it's why the x-intercept and y-intercept are very valuable and useful for the scenarios we're doing. All right, but this still looks like a lot of algebra. And I bet there's a way we can make this even easier. And that's what we're going to look at next. So let's look at this equation again. We know that we started with 2x plus 3y equals 12, and we did all these steps. But here's what I'm going to notice. The x-intercept's when y equals 0. That means I'm substituting the 0 right in here. And I know that when I substitute the 0, this becomes 3 times 0, and this whole term disappears. And I could get right to this line. Well, that's going to happen for all the x-intercepts. This y term is going to disappear. So when I do this, when I'm actually doing this myself, I take my finger, and here's my little graphic of my finger, and I'm going to take it and cover up the y equals 0 part, because I know that I'm going to substitute 0. It's as if that's not even there. And look what I have left over. 2x equals 12, which is this line right here. So I could actually skip all this stuff, and if I write this heading down, cover it up with my finger, I can go straight to this, and then I'm one step away from my answer. And that's going to be really valuable. The same thing happens when you're doing the y-intercept. It's when x equals 0. So I can take my finger, and because x is going to be 0, it's going to disappear. And I'll be just left with 3y equals 12. And all of this then isn't necessary. And I could start right at this line, 3y equals 12, divide both sides by 3, and I get my y-intercept. So doing this is totally acceptable because we're writing these headings down. So if you write these headings down, we can skip all the way down to this and be one step or maybe 2 steps away from our answer. And that's what we're going to practice now.